Hello students, welcome to Unacademy. This is your KP Sir, Krishna Prakash. Today our discussion is related to 2016 GATE Environmental Engineering in Civil Engineering Solutions. So myself, Krishna Prakash, I taught more than 150 batches of the students. Several thousands of students gain knowledge from me. I will teach the subjects of environmental engineering, hydrology, irrigation, open channel flow. My code in Unacademy is KP Civil. Okay, we'll enter into the session. 2016 GATE Civil Environmental Engineering. All questions of environmental engineering in 2016 set 1 and set 2 both we are going to solve here. Like this will release for 20 years of GATE, GATE 2001 to 2020, 20 years of GATE solutions I am going to release as soon as possible. Okay, spread this information to your friends also. In YouTube we are having GATE 2001 to 2020 solutions by KP Sir. Spread the information to your friends. Okay. And before going to start, there is a small announcement. This 29th September, I am going to start a new batch of environmental engineering in Unacademy plus course, paid course, full length GATE and ESE, which is going to start 140 hours. And hydrology and irrigation, I am going to teach 120 hours. So join Unacademy with my code KP Civil or Engineering Guru. Take plus subscription and get the knowledge. Okay, we'll move on. The hardness of groundwater sample was found to be 420 milligram per liter as CaCO3. A softener containing ion exchange resins was installed to reduce total hardness to 75 milligram per liter. Before supplying to 4 houses, water is supplied to how many houses? 4 houses. Each household gets treated water at a rate of 540 liter per day. Each house will get treated water at a rate of 540 liter per day. Means what is total discharge? 4 houses, each with 540 liter per day. 4 into 540 liter per day is the total discharge. 2160 liter per day. 2160 liter per day is the total discharge. The efficiency of softener is 100%. Bypass flow rate is very typical question. Your analytical and reasoning thinking is tested by this question. Be careful. Read the question properly. Efficiency is given 100%. 420 mg per liter of CaCO3 reduced to 75. If efficiency is 100%, 420 reduced to 0. Clear? 420 must be reduced to 0 if efficiency is 100%. But here 420 mg per liter reduced to 75. But 100% is efficiency. 100% is efficiency. How is this possible? Tell me, my dear students, how is this possible? Total discharge Q. Total discharge Q started its journey, traveled to water treatment plant. What is water treatment plant? A softener. Ion exchange resin softener. And then water is supplied. And then water is supplied to 4 houses. 4 houses. And efficiency of softener is given 100%. What is the starting total hardness? Starting total hardness is 420. but 4 houses has received water with what hardness? 4 houses has received water with hardness of 75. How efficiency 100%? But 4 houses receives not 0 total hardness, 75 total hardness. What is the reason? Reason behind this, 100% of water is not going to softener. Some amount of water bypasses some location, water, some quantity, some discharge of water, skip the process of treatment. Skip the process of treatment and then supplied. See, I will divide this discharge into 2 components. I am differentiating the discharge into 2 components. First component A, which is participated in softening, 100% of its hardness is removed and achieved total hardness of 0. pH of A will give it as 0. 100% removal of hardness is achieved. pH of A 0. Component B, QB, which is called bypass flow, which skips regular path. Treatment is not done properly. No treatment, not even properly, no treatment. And with THB, what is THB? 420. So total hardness of 0 and total hardness of 420 combined and sent to 4 houses resulted total hardness of 75. You understand? Again I am repeating. Total discharge divided into 2 parts. Part A undergone treatment and with 100% efficiency, THA is reduced to 0. THA is reduced to 0. Part B not at all participated in treatment. With the same total hardness, it is mixing with A. QA and QB mixed here, then supplied to 4 houses with the resultant total hardness of 75. So resultant total hardness, weighted average we can use here. pH resultant is equal to QA into THA plus QB into THB divided by QA plus QB. Weighted average we can apply here, is it not? Now, what is the pH resultant? pH resultant is 75. QA you don't know. THA 0 plus QB you don't know. THB 420 you can take divided by total discharge. 4 houses with 540 given 2160. 2160. So 2160. As total hardness of A is 0, total QA into A 0 is 0. Now you solve for bypass flow rate. Solve for QB, bypass flow. That is only bypass flow. Na? QB is only bypass flow. Na? What you are getting? Tell me the answer. What you are getting? 385.714 liter per day. This is the answer. Got it? Clear? Very easy. Na? Analysis of the question is very important. Step by step you can analyze water is skipping. You understand the point? Bypass flow. Water bypasses the treatment, skipping the treatment, so that you are achieving bypass flow. We'll move on to next question. effluent from industry A has a pH of 4.2. Effluent from another industry B has a double the hydroxyl concentration. Double the hydroxyl concentration of A. pH of effluent from industry B will be a simple question, most simple question. pH of A 4.2. So its hydrogen ion concentration we can write down 10 power minus 4.2 mole per liter. And so we can write down OH minus ion concentration 10 power minus 9.8 mole per liter. Is it not? Simple. 14 minus 4.2. 14 minus 4.2, 9.8 only. So OH minus 10 power minus 9.8 mole per liter. Then what is OH minus of B? OH minus of B is twice, 2 times the OH minus of A. 2 into OH minus of A will consider 2 into 10 power minus 9.8. Now, POH is equal to minus log 10 into 2 into 10 power minus 9.8. That is OH minus. So we will get POH of B. Is it clear? OH minus of B is equal to 2 into OH minus of A. 2 into 10 power minus 9.8. So minus log 10, 2 into 10 power minus 9.8. We are getting 9.5. POH as 9.5. What is pH now? pH is equal to 14 minus 9.5. What is your answer? 4.5. This is the answer. Whose pH? pH of B. Is it not? You are getting now? pH of B is equal to 4.5. This is the answer. Simple question. Just you need to know pH POH conversion. Question is easily completed for you. Okay? A sample of water has been analyzed for common ions and results are presented in the form of a bar diagram. So this is shown in the form of a bar diagram. Very important. Concentrations are provided MEQ per liter, milli equivalent per liter. Very important. Calcium 2.65. Calcium plus magnesium both. Calcium plus magnesium both 4.10. Bicarbonate 3.30. We don't want remaining because the question is about non-carbonate hardness. Is it not? Non-carbonate hardness. What we require to estimate non-carbonate hardness? We need total hardness and total alkalinity. If you know total hardness and total alkalinity, you will get the value of non-carbonate hardness. So, first estimate pH and pA. Total hardness in mg per liter as CaCO3 is equal to sum of concentrations of calcium and magnesium. Sum of concentrations of calcium and magnesium into 50, which is considered in milli equivalent per liter. Which is considered in milli equivalent per liter. That is given here. What is the value? Sum of calcium and magnesium. We will take here the sum of calcium and magnesium 0 to end of magnesium 4.1. So simple, you can take it as 4.1 into 50. 4.1 into 50. you will get 205 milligram per liter as CaCO3. This is total hardness. What is then total alkalinity? Total alkalinity is equal to, from the given ion concentration, given ions, bicarbonates in milli equivalent per liter into 50, because carbonates not provided. If not provided, do you consider it? Carbonates not provided, no need to consider, only bicarbonate. 3.30 given. 3.30, you will consider it. Total alkalinity is equal to 3.3 into 50, 165 mg per liter as CaCO3. 165 mg per liter as CaCO3. Now what is the relation? pH greater than Ta. So what happened if pH is greater than Ta? Tell me what happened, pH greater than Ta. CH is equal to Ta. NCH, non-carbonate hardness. This is only required for us. Non-carbonate hardness is equal to pH minus Ta. So what is pH? Total hardness 205. What is Ta? Total alkalinity 165. So what is non-carbonate hardness? Tell me. What is non-carbonate hardness? Final answer you are getting 40. So non-carbonate hardness is 40 mg per liter as CaCO3. 40 mg per liter as CaCO3. So what we can take now? Option A. We'll go ahead with option A, non-carbonate hardness. Clear? Only thing you remember, milli equivalent per liter is provided. Just multiply with 50, you convert to mg per liter as CaCO3. Next question. A water supply board is responsible for treating 1500 meter cube per day of water discharge. A settling column analysis indicates overflow rate of 20 meter per day. Discharge is 1500 meter cube per day. Overflow rate V0 is given 20 meter per day. That overflow rate of 20 meter per day will produce satisfactory removal of a depth of 3.1. It is decided to have two circular settling tanks, not one, two circular settling tanks in parallel. Required diameter of settling tank is now surface area. First we estimate surface area is equal to discharge by overflow rate 1500 by 20. Surface area is equal to discharge by overflow rate na 1500 by 20. What is the answer? 1500 by 20? 75 meters square. 75 meters square. Now how many tanks are there? 2 tanks. So what is the surface area of each tank? 2 tanks are there. 1 tank surface area. 75 by 2 na? 37.5. 1 tank surface area 75 by 2, 37.5. Now surface area is equal to pi by 4 d square, which is equal to 37.5. Get d value, determine d value. You will get it in answer. Diameter of each tank. Determine diameter of each tank. Surface area is equal to pi by 4 d square. That value is equal to 37.5 meters square. From that, solve for D. Solving for D, you are getting 6.9 meter. 6.9 meter. This is the diameter of circular tank to treat 1500 meter cube per day by using 2 tanks. Okay, we'll go ahead. Crown corrosion in a reinforced concrete sewer is caused by H2S, CO2, methane, ammonia. Crown corrosion is always the property of hydrogen sulfide, H2S. Crown corrosion is always the property of H2S only. The 2-day and 4-day BOD values of sewage sample are 100 milligram per liter and 155 milligram per liter respectively. Value of BOD rate constant. We'll write down 2-day BOD Y2 L0 into 1 minus e power minus K2, which is equal to 100. Same we can write down for 4-day BOD Y4 L0 into 1 minus e power minus K4. Because here time is 2 days, here time is 4 days. The value is taken as 155. So this is equation 1. This is equation 2. Both K values are same. Both K values are same. So L0 is same, so that it was cancelled. L0 is same, so that it was cancelled. K values, equations 1 and 2, solving equation 1 and 2. What is the K value you are getting? K is equal to 0.3 per day you are getting. BOD rate constant, K value. Solving equation 1 and 2, you are getting BOD rate constant K value 0.3 per day. Okay, you go ahead. Again, question from BOD, set to 2 marks. For a wastewater sample, 3-day biochemical oxygen demand at incubation temperature of 20 degrees means Y3 20. 3-day 20 degrees Celsius BOD estimated as 200 milligram per liter. Estimated as 200 milligram per liter. Taking value of first order BOD rate reaction K 0.22 per day. 5-day BOD of wastewater at incubation temperature of 20 degrees Celsius. Y5 at 20. What is the value? Simple. You can calculate. You can estimate Y3 200 mg per liter is equal to L0 into 1 minus e power minus 0.22 into 3. So that is equal to 200. Now using this, 200 is equal to L0 into 1 minus e power minus 0.22 into 3. You will get L0 value. From this you are solving L0 200 divided by 1 minus e power minus 0.22 into 3. You will get L0 value 413.95. L0 is equal to 413.95 mg per liter. Now apply same equation for Y5 at 20. So universal equation L0 into 1 minus e power minus kt. L0 413.95 1 minus e power minus kt, k 0.22 time 5 days. Universal equation. BOD at any time and at any temperature is equal to L0 into 1 minus e power minus kt. We are using that universal equation at any time and at any temperature. We are getting what we are getting? 5-day BOD at 20 degrees Celsius, which is 276.15 milligram per liter. 276.15 milligram per liter. Clear? Very simple model. So remember, most of the times GATE will carry BOD question. Without BOD, mostly we don't have GATE question paper. Remember that point. Oh, match the following. Activated sludge process. What the activated sludge process uses? In the previous 2018 paper also I told, activated sludge process uses heterotrophic bacteria. Activated sludge process uses heterotrophic bacteria. Raising of sludge. Raising of sludge is carried out by denitrifiers. Rising of sludge is carried out by denitrifiers. Conventional nitrification. Conventional nitrification is carried out by autotrophic. The bacteria which synthesize their own food, autotrophic bacteria, and the process is called conventional nitrification. Biological nitrogen removal. In STP, in sewage treatment plant, we use nitrifiers and denitrifiers. Nitrifiers and denitrifiers in STP we are performing biological. So activated sludge process, heterotrophic bacteria 3, raising of sludge, denitrifiers 4, conventional nitrification carried out by autotrophic bacteria, biological nitrogen removal in STP by nitrifiers and denitrifiers. So what is the matching? 3, 4, 2, 1. 3, 4, 2, 1 is the match the following question. Okay. Precursors to photochemical oxidants are NOx, volatile organic chemicals, and sunlight. If it is industrial smog, then we will go for SO2. But photochemical smog and photochemical oxidants. Question is about photochemical smog and photochemical oxidants. Option A, NOx, volatile organic compounds, sunlight. The atmospheric layer closest to the earth's surface. Do you remember it? In our air pollution YouTube class itself I told, the first layer is a troposphere. I have drawn it in a diagram also, followed by stratosphere, followed by mesosphere, followed by thermosphere. So 4 layers are going on. So what is near to ground level? This is the layer which is nearest to our ground level. This is the layer which is nearest to our ground level. Troposphere. So answer is troposphere. Answer is troposphere. It was decided to construct a fabric filter. Wow, air pollution control equipment question. It was decided to construct a fabric filter using bags of 0.45 meter diameter, 7.5 meter long, 7.5 meter long. Length and diameter of each individual bag, we'll write down. Length is 75 meter, diameter is 0.45 meter. length and diameter of each individual bag provided. For what purpose? For removing industrial stack gas containing particulate matter. Expected rate of airflow 10 meter cube per second. Discharge. Filtering velocity 2 meter per minute. So we'll write down discharge 10 meter cube per second. Velocity 2 meter per minute. So I am converting discharge also meter cube per minute. 10 into 60 meter cube per minute. Good. Minimum number of bags required for continuous cleaning operation. Number of filter bags required. You just imagine, even though you have not studied fabric filter topic, you just imagine filtration you studied in water treatment operations. Number of filters required, N is equal to, will take total surface area divided by individual surface area. This is only formula, TSA by ISA. Total surface area divided by individual surface area. Surface area for each filter. Now TSA, simple, total surface area, discharge by velocity. Discharge 10 into 60, velocity 2, so we can take 300 meters square total surface area. Individual surface area, pi dl, because it is a cylindrical cotton bag, na? Pi dl. So we will solve for N, number of cotton bags required. Total surface area 300, individual surface area pi dl, pi into 0.45 into 75. So how many number of cotton bags required? How many number of filters, individual filters required? Simple formula calculation only. You will get 28.29. Highest value you can take it, 29 is our answer. Don't take lower value, take higher value, 29 is our answer. So, we'll go for option B. Okay? Clear? Next one. An electrostatic precipitator with a 5600 meter square area of collector plate area, 96% efficiency. Treating 185 meter cube per second of flue gas from 200 megawatts thermal power plant. Here I will tell you, before reading the entire question itself, I will tell you efficiency formula for electrostatic precipitator. Efficiency of electrostatic precipitation is equal to 1 minus e power minus A into K. K what we can take? W by Q. K into W by Q whole power into 100. 1 minus E power minus A into W by Q. 1 minus E power minus A into W by Q into 100. So substitute given data. 96% is equal to 1 minus E power minus 5600 into W. W not given. Discharge 185 into 100. You will get W from this one. You are going to determine W. W is equal to, you will get it now, W 0.1063. W is equal to 0.1063. We'll continue. Next question will continue. It was found that in order to achieve 97% efficiency, collector plate area should be 6100. In order to achieve 97% efficiency, collector plate area should be 6100. In order to increase efficiency to 99%, electrostatic precipitator collector plate area. This is not required. 97%, 6100 not required because already you have W, you have Q, you can solve it. Considering 99% efficiency, 1 minus e power minus a into W. W solved 0.1063 we determined. Discharge is constant 185 into 100. Solving, you will get area of electrostatic plate, collector plate area A is equal to 8012.38 meters square. The only one formula you need to know here, efficiency of electrostatic plate is equal to 1 minus e power minus a into W by Q into 100. You will get the value A is equal to 8012.38 meters square. The sound pressure of the faintest, the sound pressure of the faintest sound that normally healthy individual can hear. So what the healthy individual can hear? 20 micropascal reference sound pressure level. A common healthy person, common man can hear lowest possible 20 micropascal. A noise meter located at a distance of 30 meters from a point source is recorded 74 decibel. A noise meter located at a distance of 30 meters from a source. Source is located here. Noise meter is at 30 meter distance. Noise meter is placed. Noise meter is placed at what distance? 30 meter distance. Measured noise as 74 decibels. Measured noise as 74 decibels. Source is located 60 meters. The reading when it is distance is increased to 60 meters. Noise meter at 60 meter. What is L value? What is L value? Simple. No? Consider this is L1, this is R1, L2 is required, R2 given. L2 is equal to L1 minus 20 log 10 R2 by R1. Distance increases, noise value decreases. Simple logic. So we are subtracting 74 minus 20 log 10. What is R2 by R1? R2 60 meter, R1 30 meter. So what is L2 we are getting? L2 67.97 decibels. Take the value 68. So only thing you need to know formula. L2 is equal to L1 minus 20 log 10 R2 by R1.
Hey, I will challenge you in PUBG. Will you come online to play?
No, I have online GATE class. I don't want to miss it.
Who is teaching?
Top faculty of civil engineering in India, KP sir on Unacademy. I am a big fan of his teachings.
Oh yes, I have also heard about KP sir. I am willing to join the class.
It's nice. Take subscription in Unacademy using KP Civil code. You will be benefited more. Okay, let's crack it!